Hi friends, welcome to my channel NM Learn My Courses with Namani. This is the third lecture of thermodynamics, and in previous class we studied about types of boundaries and types of systems and some of the properties of thermodynamics. And today we are going to discuss about what is the state of the system and what is the Gibbs-Phase rule, why we have to use Gibbs-Phase rule, and thermodynamic properties, and also we will discuss about ideal gas equations. These topics are important for competitive exams, so I will discuss formulas and also I will explain some of the example problems also, so that you can understand very easily. Coming to the today's lecture, I am going to start with the state of a system. If you see the definition, actually state represents the condition of the system. Okay, state represents the condition of the system, and this condition which is identified by the properties. In previous class we studied about properties, like what are the properties, like intensive properties and extensive properties. So we studied about types of properties. So with the help of these properties, like whatever pressure, volume, temperature, etc., so these are all comes under properties. When we fix these properties, if we take any substance, so if we fix all the properties of that substance, then that substance is said to be in one particular state. Okay, I will give one example so you can understand easily. So firstly, I am taking 1 cup of water. Okay, I am taking 1 cup of water and I am keeping this cup in fridge. Okay, I want ice cubes from this cup. So at 0 degrees centigrade, we know that water melting point is 0 degree centigrade. At 0 degree centigrade, this water is become ice. Okay, so at 0 degree centigrade, this ice water become ice, and we are maintaining these ice cubes at the same temperature, like 0 degrees centigrade only. Just assume we are maintaining these ice cubes at 0 degrees centigrade only. So we are fixing this temperature, like some, and also we inside the like inside the fridge some pressure is also there. So we are fixing this temperature and pressure to maintain this water into ice cubes. So it is in one particular state. So this water in one particular state at some temperature, constant temperature T and constant temperature P, like we are fixing temperature 0 degree centigrade and some pressure, so that then these ice cubes, so first in first state it is in water, so next it is comes into ice at particular temperature and pressure. After fixing pressure and temperature, this water become into ice, it comes into the one state. So these ice cubes at constant pressure and temperature, which is nothing but state. Understood? State represent the condition of the system. And also this, okay, wait. So if all the properties of the system have fixed and which have definite value, then the system is said to be in state. Understood? All the properties of the system have been fixed and it will have definite value, then the system is said to be in state. And we discussed about water which is having which we are maintaining some pressure and temperature, like these are the properties we are fixing. So all the properties, like these are the properties of water we are fixing. So all the properties of the system means here water have been fixed. So we are fixing at particular temperature and pressure, and at definite value means temperature at 0 degree centigrade and some pressure P. So we are fixing and it have some definite value. Then this system, then this water, like this water here become ice. This ice is said to be in state. So in this way, state can be state can be defined. I think everyone understood. And now we will move to the another topic. that is Gibbs phase rule, and we studied from this Gibbs phase from the our childhood, and now also we have to study. We know that Gibbs phase rule formula, so which is P plus F, which is equal to C plus 2. We know that P means number of phases and F means degree of freedom. Degree of freedom means minimum number of independent properties required to fix the state of a system. Understood? Minimum number of independent properties which are required to fix the state of the system, that is nothing but degree of freedom. And this is the number of components. C means number of components. So components means, if we take components means, that is the chemical form of any component. So if we take water, the chemical form is H2O. So this is the one component. In this way, phase, okay, phase means we know that water having phases, with having solid phase, liquid phase and gaseous phase. So water having three phases. So if you see the definition, Gibbs phase rule, P plus F equal to C plus 2. So P means number of phases, F means degree of freedom and C means number of components. And how to find the degree of freedom, I will explain with simple example. Okay, 1 minute. Okay, next I am taking the three cases. Okay, I am taking in this example water as the system. Okay, in case 1 I am taking one vessel. Okay, I am taking one vessel and it which having water. Okay, and also in second case I am taking both water and steam. Okay, in second case I am taking both water and steam, and in third case I am taking both water, steam, ice. Water, ice, steam. Okay, so how to find the degree of freedom for each case we will see in detail. Okay, and we know that P means number of phases. So in first case, if we see the here first case, that phase which is nothing but only water. So P equal to 1. We don't know degree of freedom. We have to find the F value. So number of components, if we see here, number of components is only water. The chemical we have to write for every system, we have to write the chemical formula. So water chemical formula is H2O. So here components is 1. So if we write in this equation these values in this equation, then we will get the degree of freedom. If we see here 1 plus F, which is equal to C plus 2. So here C means 1. Okay, C means 1. So this one get cancelled and F equal to 2 we got. So for this, for case 1 we are getting phase is 1 and we don't know the degree of freedom, and components is 1. So if we substitute these values in this equation, we will get, okay, sorry, so we will get here we got the degree of freedom F equal to 2. And what is this meaning, I will explain later. Okay, and next one we will take case 2. So here we know steam, here there are two systems, one is water and one is steam, and if we write the chemical formula of steam, that is same as water, H2O only. So if you see here phase, P equal to, phases are water is liquid phase and steam is vapor phase. So here two phases are there in this case, and also number of components is 1, because the chemical formula for both water and is steam is same. So the number of components is 1. If we substitute P and C values in this Gibbs phase equation, we will get 2 plus F equal to, sorry, 2 plus F equal to, C is nothing but 1 plus 2. So these two get cancelled and F equal to 1. So we will get F equal to 1 in case 2. Okay, I will write again. So we got F equal to 2 in first case, and here we got f equal to 1 in second case. So whatever I told, I've written here. And if you see the case 3 here, you also stop the video and guess how much you are getting here degree of freedom. Okay, and now I am telling here we have phases. How many phases are there? Steam is vapor phase, and ice is solid phase, and water is liquid phase. Here we have 3 phases, and number of components here both having chemical formula same. So H2O, H2O, H2O for ice, steam, water. So components is 1. So if we substitute these values in this Gibbs-Phase rule equation, we will get F equal to 0. So I am writing here. So if we see here, in first case we got the f is equal to 2, and in second case we got f equal to 1, and in third case we will get f equal to 0. That means here degree of freedom we are getting 2, means for this system we have to fix the 2 state points, then this system is comes under the state. Okay, so if you see the case 3, we are getting degree of freedom which is equal to 0. That means no need to fix any point to represent this system, because if we see the triple point diagram, we will here that point is fixed, like a pressure of triple point water and temperature of triple point water is fixed. We know that temperature of triple point is 0.01, like wait, I will write here. If we see the triple point temperature of water is 0.01 degree centigrade, and pressure of a triple point of water is nothing but 0.6117 kilopascal. Okay, kilopascal. So sorry, bear with my writing. In this way there is no need to fix the state points for this case 3, and we have to fix one is pressure or temperature in case 2. Here we have to fix pressure and temperature for this case. In this way we have to find the degree of freedom value. Okay, I think everyone is understood. And so this degree of freedom which we are finding for to know the how many independent properties have to required for to fix the state of the system. Okay, I will tell you again. This degree of freedom we are finding to know the how many independent properties have to fix to get a state of the system. So here we got these values. If we got f equal to 1, means one independent property is required to fix this state of the system. For this only we are finding the degree of freedom. Next we will see the what is the thermodynamic process. And thank you for watching. If you feel that this lecture is useful to you, please like, share and subscribe to my channel, and you can share to your friends so that they will also get beneficial from this class. Thank you everyone for your support.